In this short talk, I'm going to explain a methodology for teaching software skills by drawing on a case study from my own practice. So, by way of an overview, I'm going to start by talking about the software that was used. I'm going to then talk about the case study context, the evaluation methodology, the coursework tasks that students performed during this process, and then link that with some findings, and then go into a bit of a thematic analysis that goes into more detail. I'll then round off with a summary and some concluding thoughts. So process simulation is a software tool that gets used by chemical engineers to understand industrial chemical processes, and it aids the design of new chemical plants, and it can be used to troubleshoot or optimize existing processes. A chemical plant flow sheet is constructed and data about the operating conditions is entered. The software can then simulate the operation of the chemical plant. Outputs from this software simulation include material and energy balances and other information, and this can facilitate equipment design or assist with optimization of the process. So the context for this case study is process simulation being taught to first year students, and this was for 20% piece of coursework for a 20 credit module, and it was taught over 6 sessions, 2 hours per fortnight, and they were using the Pro 2 9.2 steady state simulator. Evaluation methodology draws upon an online survey, questionnaires and semi-structured interviews, thematic analysis of the interview transcripts using a template, and NVivo 10 was used to code the interview transcripts. So the coursework was based around a number of tasks that the students had to complete in sequence, each task built from one to the next, and it was really essential to do the first task followed by the next task in order to be able to follow through and learn how to use the software. So task 1 was all about the basics of using Pro 2, and there were 7 key steps that had to be followed, and that was it. This piece of the coursework, this task, was all about getting the students to understand those steps and be able to follow those steps. And they built something quite simple. There was 2 streams being mixed and then going into a pump, so quite trivial really, but what was important was the learning that was happening in terms of seeing these 7 steps in action. And there were videos to support this, so a series of videos that took them through step by step to see how to follow the 7 steps. Task 2, again supported by videos, actually broadened out into some different unit operations, and that allowed students to see sort of a broader perspective of what the software could do. Something that interesting happened in this part was that students would follow the video and click run and it wouldn't work, and I had to sort of remind them, well, did you follow the 7 steps? And this just really reinforced the learning from task 1, because often the video hadn't covered everything. They needed to have set some of the bits and pieces up that weren't covered in the video. Task 3 was about putting together this knowledge. I gave them an outline flow sheet as shown here, and then they had to build this and they had to add the operating information, so I gave them an outline of that, but there was no videos this time. This was about them figuring it out and using what they'd learnt, and I was pleased that a lot of them could do this. There was perhaps they got tripped up a little bit on the splitter and specifying the wrong stream for a set flow rate, but on the whole they were able to do this. They weren't so well able to troubleshoot at this stage, so we did have to give them a bit of a prompt if it wasn't working, particularly around that splitter specification. Feedback for this first 3 tasks, they said that the video tutorials were a good way to learn the basics of using Pro 2. They either agreed or strongly agreed there, and they also felt confident about using some of the basics of the software after completing these first 3 tasks. From the interview feedback, there was positive comments as well about finding the videos helpful, and the fact that they showed exactly what you had to do. That helped a lot, and also they liked the ability to take things at their own pace rather than feeling rushed with someone saying something at the front, but they could pause, they could rewind, they could check what they were doing. Task 4 then was a bit more involved. At this stage I gave them an electronic copy of an existing simulation, and they had to reverse engineer that to create a set of instructions. So they were working in teams of 4, and they really had to dig into the software and understand what was going on to do this. The third step of this task was then to follow each other's instructions and demonstrate that they had learned something about more advanced features. The tasks, the actual simulations for this task were quite complicated. There's a list of them there, and you can see from these flow diagrams they're quite involved, but they were able to tackle these and they really gave it a good go. Online survey feedback, less agreement about video tutorials being a good way to learn advanced features, and that's kind of the point here, that they're trying to do this by discovery based learning now, by reverse engineering an existing software simulation. But there were some videos that were there to help them. But also, the other question that's shown here, that they strongly agreed that they felt confident about using some advanced features of Pro 2 as a result of completing this task. Interview feedback, again, they liked this reverse engineering technique, positive comments around this, they found it helpful. The interviews the full transcripts were analysed using a template, thematic analysis, and there were several emergent themes that came out from this, and we'll go through these and sort of see how these were put together to give a model of process simulation pedagogy. So the students, as part of the interview process, were asked to reflect on the Dreyfus and Dreyfus 5-stage model of skill acquisition, and to try and think about at which stage they were at as they went through the coursework. So there were sort of descriptors for if you're at the novice stage, you have little or no previous experience, and you're concerned about your ability to succeed, and there's a whole list of things there that sort of describe where you might be feeling, what you might be like at a novice stage. Then there's more detail for advanced beginners, be able to start to break away from some of the rigid rules, be able to start to try tasks on your own, but still having trouble with troubleshooting. At the competence stage, there are a whole host of other sort of descriptors that they reflected on and looked at, and again this was useful for them to sort of think about how they were developing. There was also the proficient stage and the expert stage. They didn't really necessarily feel that they were getting to these stages, but it was useful again for them to look at these and reflect on how they might develop in the future. So in terms of this, there was a definite link between these different stages of skill acquisition and the different tasks, and also there's a progressive mapping of the learning modalities and the sort of levels of cognition as they went through the different tasks. So that starts to sort of build up a picture for us, and there were definite phases of learning. Task 1 and 2 was a sort of early phase of learning where they were getting the basics, supported by videos, and they were really at the novice stage and then starting to develop into the advanced beginner. Task 3 really seemed like a bridge through to a later phase where they were developing much more in-depth skills, starting to develop features of the competent, maybe even a bit of the proficient skill level, and this was really underpinned and driven by discovery and inquiry based learning, and started to tap into and develop higher order thinking skills. One of the themes that came out was around metacognition and motivation, and there were various comments that sort of meant that they were really demonstrating that they realised the need for attention to detail, awareness of their own limitations, developing a desire to learn more, and seeing the importance of the skills that they were gaining, and also finally reflecting on and recognising their developments and achievements. And of course this sort of metacognition is really important, and this motivation, because we want students, they come in studying the subject, but we want them to develop and graduate to become the subject. We want them to become a professional in that area, so they go from studying chemical engineering to becoming a chemical engineer, for example. So there's some stuff around Bloom's taxonomy and the affective domain which is quite useful when thinking about this. Developing knowledge was another theme that really underpinned all the way through as they went through these different phases of learning. I'm not going to go through these in detail, but that was a definite underpinning theme. And what I will say about this is that in terms of Bloom's taxonomy for the cognitive domain, it's foundational to actually learn this basic knowledge, because then we can use that as a foundation to build on the higher order thinking skills. Often we're trying to say, well, let's just get to the higher order thinking skills, but actually we do need a foundation of this knowledge to be able to build on. Barriers to learning, there was things around access to software, issues with group work. I mean, group work is a perennial issue, and lots written about that. The troubleshooting and the fault finding was certainly something that came up a lot as a barrier. Then there were particular practical things around session spacing, and also some stuff around understanding and using complicated advanced features, which is fair enough. It's quite complicated software, and they were by no means going to become experts by the end of it, but I was trying to introduce them to this. So this all comes together to create this learning model for process simulation pedagogy, and you know, there are really useful insights coming from this that I'm now applying in other areas of the course. So it's not just a fancy picture, but there's actually really useful insights coming from this. So in summary, the survey responses provided a positive picture of student perception of the training. Evaluation of interviews revealed key themes in the learning process. Video enhanced learning supports initial skill development, whereas the inquiry-based learning supports the deeper learning and higher order thinking skills. And these findings have led to new insights that are informing teaching elsewhere in the course. The reference for the full paper for this work is shown there, and some concluding thoughts. It's good to support basic skill acquisition with software with videos. That works really well because the students can go at their own pace, they can mimic what's being shown, and that is an improvement on just being shown from the front, because if there's 7 clicks to do one thing and if they get 1 click, then they've sort of had it, whereas this allows them to go at their own pace and to really develop the basic skills step by step. And it's also useful to scaffold early tasks to guide the students through. It's also useful to encourage the students to find and fix errors in the formative tasks before they complete the summative ones. So often the students were following the video or following the instructions to build a simulation. They then had to make sure that was working properly based on the results that they're supposed to be getting. If it wasn't working properly, if it wasn't giving the results as expected, they had to fix that, either by going back over the videos or going back over the instructions. And so it was really good to encourage them to fix and find errors in the formative tasks before they then did the summative task, which was an online test. Once they uploaded their simulation, there was a test that they had to take, again based on using the simulator. And it's good to set open-ended problems to support advanced skill development. So I hope that's been useful, and thanks for watching.